All right, this is number 29, chapter 12. And in this case, we have a kind of a weird contraption here. It's like this and this, where this distance, total distance here, is 2 meters. This block is 1 meter from here to here. This is a 4 kilogram block. This down here is a 1 kilogram block. Okay, and we want to figure out the center of mass of this combination of two blocks together. So to figure out the center of mass, we have to say, oh, okay, where is it going to be? Well, we got to do it. Technically, we got to do it for both x and y direction. But I think they don't care about the y direction. Let me look real quick. Just to remind myself, 29. Yeah, they're balancing it on a pivot here. So some pivot point right here, and they need to know this distance. So we only care about the x direction here. We need to know what that distance is to put the pivot to balance it. Essentially, we need to find the center of mass in the x direction only. So x direction. In the x direction, we're going to have mass total, x center of mass, is going to be equal to m1, and then r1x plus m2 r2x. All right, so we need the x coordinate of each of those. We're going to use our reference point as this 0 point over on the left side here, because that's where we want to get d reference from. So we look at these two pieces and we say, oh, well, if I break this down, so this rectangle up here, the center of mass of it is going to be right there, halfway in the middle of this 1 meter, or this is going to be a ½ meter here. But from this point over here to the center of mass, that's 1½ meters. So if I'm calling this M1 up here, and this is M2 down here, over here, my x center of mass is going to be equal to 1 over the mass total, times M1, which is 4 kilograms, times the distance, which is 1.5 meters. See how I got 1.5? It's 1.5 all the way to there. Okay, plus M2, which is the bottom one, but the bottom one, the center is going to be right here, halfway in between, but half of 2 meters is just 1 meter, so it has a mass of 1 kilogram times the distance of 1 meter. Okay, so the x center mass is going to be equal to 4 times 1.5 plus 1 times 1 is just 1 all over the total mass. Well, the total mass is just going to be 4 plus 1. 4 kilograms plus 1 kilograms. You get the x center mass is equal to 1.4 meters. So 1.4 meters from this side, this has to be equal to d, is where you're going to put the fulcrum to balance that. All right, that was number 29. Fairly easy one.